So let's look at this example of series parallel circuit. Now, I wanted to include this circuit because it's not obvious what where your connections are for your resistors. I mean, you can probably see that um, you've got R1 and R2 in parallel here, and you can probably see that R4 and R5 appear to be in parallel, but some of the other connections are just a little bit hard to see. Okay, so here's what I suggest. When you have something like this and you're not quite sure, even if it doesn't look like this, if you're not quite sure what the connections are, I like to pull out some colored pencils and figure out what is connected to what in the circuit. And then I can start kind of making connections with series and parallel. So I'm going to start at the positive terminal of my source. And I'm just going to trace any lead to where that's connected in my circuit. So just stopping at resistors or at other sources. So I see that it's connected there and there. I see it's connected up here and up here, and I think that's everywhere that's connected to the positive terminal of my voltage source. Now I'm going to do the same for the negative terminal. Let's just see where it's connected. It's obviously connected to ground, to R5, to R4, to R1, R2, and R3. Okay. So then I would take any other connections that I haven't colored yet and color those in to see other connections. But what I realize is after doing this, every resistor has a green side. Do you see that? Or 1, 2, 3, 4, and 5 all have one end that is connected green. All of the resistors are 1, 2, 3, 4, 5 also have a side that's connected orange. So that means all of these resistors are in parallel with our source. So we found that this circuit just got a lot easier to analyze, and we could redraw the circuit where we have all of our resistors in parallel with the voltage source. I'm going to move this down just a little bit. R1, R2, R3, R4, and R5. Okay, not the neatest circuit I've ever drawn. But I'm kind of drawing up in the air. I'm not real good at it yet. Okay, so we've got 32 volts here. And R1 is 16 ohms, R2 is 8, R3 is 4, R4 is 32, and R5 is 16. Okay, so what does that do for us? Well, we now understand that we've got 32 volts across each resistor, right? 32 volts here, 32 volts here, here, and here. Okay, why? Because they all share a point in common with the positive terminal of the source and with the negative. So that means there's 32 volts drop across each. Using Ohm's law, we see that we can now find the current through each of these as well. Using Ohm's law, voltage divided by resistance gives you current. So 32 divided by 16 means we have 2 amps of current there. 32 divided by 8 means we have 4 amps of current here. 32 divided by 4, 8 amps of current here. 32 divided by 32 is 1 amp. And 32 divided by 16, 2 amps of current. Now, what does that mean for us? Now I'm going to go and plug in those currents back into my circuit, my original circuit. And I'm going to make sure that they go from green to orange, okay? Because that voltage drop should be from green to orange. That's where the positive terminal is, the green, and the negative is the orange. So for my R1, I've got 2 amps going from green to orange. For my R2, same direction, but now I've got 4 amps. For R3, I've got 8 amps going from green to orange, so that's going this way. And I'm just writing it on both sides of the resistor just so that I have it like that. R4 is 1 amp, and it's going from green to orange, or from plus to minus. You don't have to use the colors if you don't want to. And then my 16 ohm resistor R5, I've got 2 amps, again, going from the green side to the orange side. Now, once I plug all of those in, and I'm going to go ahead and make a note that I've got 32 volts here, 32 volts here, 32 volts drop across each of the resistors. And I'm going to clean up some of the drawing that I did earlier. All right, so we've got our syncing problem fixed here, I hope. So our total resistance was 1.88, and that would give us, if we have a 32 volt source divided by that 1.88 ohms, we'd have about 17 amps of current. So as you could probably see from our step 2 here, we have 2 plus 4 is 6, plus 8 is 14, plus 1 is 15, plus 2 is 17. So that works out. Okay, so let's find some of our additional currents here. So let's just start here. I know we've got 4 amps coming in and 8 amps coming in. So that means we must have 12 amps leaving through here. So what else do we have? Right here, we've got 8 amps leaving and 1 amp leaving, so we must have 9 amps coming in here. Let's look up here. 2 amps coming in and 12 amps coming in. It means we've got 14 amps here. So 14 amps here and 1 amp coming in. So we've got 15 amps here. 15 amps and 2 amps coming in gives us 17, which, surprise, surprise, is our source current. So that works. So we'll have 17 amps over here. We don't know enough over here yet to do much more. Looking here, we've got 9 amps leaving and 2 amps also leaving. So that means we have 11 amps coming in this way. 17 coming in, 11 leaving this way means we have 6 amps this way. 6 amps coming into here, 4 amps leaving that way, leaves that other 2 right there, which works. And I think we have figured out all of our currents in our circuit.